Thank you for coming. Today we are going to look at hacking Android and iOS apps with Deep Links and XSS. So we are going to see some interesting scenarios, right? So first I'm going to show the course that we are going to deliver at CIFCon in October. And what we're going to, so first I'm going to briefly explain what is in the course, and then we will jump into deep links attacks, achieving user impersonation, bypassing authorization controls, deep links attacks to make phone calls, and then we will also look at XSS attacks and data exfiltration, and all these things we are going to do in both Android and iOS, right? So I'm Abraham Aranguren, CEO of 7 Security. If you like this presentation, maybe you like reading public pen test reports, so there's a few here. There's some public training courses there. I wrote a course for Island Security a while back about practical web defense, about hacking and defending web applications. I'm the OWASP WPF project leader. There's some presentations here. I have some certifications, so if you're interested in getting certified or whatever, maybe I can give you some advice as well. Or I can tell you over a beer about how this happened. So, yeah, there's a few public test reports. Actually, these are, if you're interested about mobile security, these two pentest reports here should be very interesting because these were about a mobile application that was mandated in all of South Korea. So both parents and children were forced to install this app by law, so that parents control when the child uses the phone and all this kind of stuff. So there's a talk about this if you're interested that you can watch on YouTube, and there's the slides about that here. And these are the two pentest reports where you can summarize as everything you should not do when you develop an Android app, right? So yeah, and these are more kind of privacy related. What kind of data is the application collecting and stuff like that. And these are more kind of general pen test reports, like more kind of looking for security vulnerabilities. So that's about me. And Anirudh Anand is also one of the authors of this course. He's a member of the #1 ranked CTF team in India, Team BIOS. This is his blog and his Twitter. He also has some nice certifications from Offensive Security and eLearn Security as well. So for this course, you're going to need at least 8 GB of RAM, 60 GB of 3D space, and we use VirtualBox because we use Genymotion, and Genymotion needs VirtualBox. So this is why we recommend VirtualBox. But for the iOS part, it really doesn't matter what you use. But in general, because we will give you a VM that is already set up for VirtualBox, VirtualBox will work the best. So now this is true for all our courses, right? So we always, in all courses, give digital copies of all training material. So you get slides, you get lab PDFs. You also get some extra bonus material, like for example, before some slides are public, you will get them in the extras menu and stuff like this. There's some lab VMs, there's some test applications, including applications from, police in some dodgy countries and stuff like this. Then the source code for the test apps. And then another thing is you get lifetime access to the training portal. So you get all future updates for free. You get step-by-step video recordings. You get the slides, the lab PDFs, and you get unlimited email support, right? So why do we do this? Because the courses are actually quite heavy. So it's really not fair to call day one because nobody finishes day one in one day. And this is because we try to keep all skills, all people happy, right? So if you are kind of new to mobile security, you still are going to learn a lot in the training, but maybe you will not finish as much during the class, but then you can continue later. And in a couple of weeks, you send us an email and we will do our best to help you both through Slack and through email. If you need to troubleshoot something or some lab that you didn't have time to finish during the class, so that is no problem, right? So that's always part of the package. So the course is divided into 3 parts. The first part is about general Android with some touches of IoT applications as well. So first we start with understanding the security model in Android, right? So the best tool for this is a tool that gives you a shell like Termuct, right? And in here, we are going to check like what happens with the SD card, what happens when you try to read files from other applications in the system, and all this kind of stuff, right? So this is a quick summary of this lab. Then in lab 2, it's more about like reversing and source code analysis. So we do some manual techniques. We also do some automated techniques. So you will learn pretty much like everything you need to know for getting around doing a mobile app assessment, right? So all the tools you need, all the techniques that you need for kind of reversing and analyzing source code and stuff like this. And then there's also like some attacks and mitigation. So you see what the code looks like, how you should fix it as well, and stuff like this. Now, lab 3 is really cool. I think it's one of the ones that people like the most, because we have like a lot of stuff about attacking. So there's like, it's very heavy on browser, but then we also have deep links on Android and attacking web views with data exfiltration. So we will see a little bit of this today. Today we will skip the Shopify biometrics fingerprint bypass, but we will do the Periscope cross-service forgery. So we are going to do this one as a demo today. I'm going to explain a little bit of the theory. And we will also do a little bit of the web views, right? So in the session today, I'm just going to do this bit, and then some other parts for iOS, right? But the Android bits that I'm going to do are these ones that I'm highlighting here. Then in lab 4, we look at man in the middle, right? All the problems with man in the middle, how to validate the application, is validate an SSL certificate correctly or not, how to test all that, how to use like DNS spoofing to do man in the middle, how to man in the middle non-HTTP protocols. So there's a lot of like all the stuff that you need basically to man in the middle Android applications. Then lab 5, we look at repackaging Android applications. So basically changing the application address. So you decompile it, you make some changes, then you install it again, and you bypass some stuff, right? So that is basically the idea. Yeah, and just what is here. So we bypass root detection, we gain file and debug access to unknown rooted devices using these techniques. We can translate APKs, and we can do things like this. And in lab 6, we have a look at instrumentation using exposed and JDWP. So we bypass root detection. We monitor what the applications are doing at runtime using exposed modules. And we look at JWP to like dynamically hook an application to bypass root detection, going like debugging the application step by step and stuff. And each day finishes with a CTF, which we never have time to do during the class because people are overwhelmed with all the material in the other labs. But this is something you can then practice from home. So this will give you like some additional applications for you to play with and stuff, right? So this is the first day for Android. Now the second day, or part 2 really, because it's for more than a day, as I said, is for iOS, right? So in iOS, first the introduction, we look at like how to install, retrieve iPass, how to get iPass from the Play Store, basically how to get started. We also touch on Corellium, so to test using a virtual iOS device if you don't have a physical one. So this is also an option, and it's also explained in this lab. And in lab 2, we look at decryption, or how to get all the decryption, all the files from the App Store decrypted, how to decompile binaries using Guidra, Binary Ninja, Hopper, you know, like all the basic essentials, you know, to do kind of reversing of iOS apps, right? So, and then how to review like data files, data protection, keychain usage, reviewing binaries, and all this. Then in lab 3, we look more at static analysis. We use some automated tools as well. We use Xcode. We look at common iOS application security checks, so finding URL handlers. We are going to do a little bit of this today for finding and exploiting URL handlers, which are kind of the deep links that I talked about before. And we will also do a little bit of this web views of data exfiltration for iOS, and yes, and attacking URL schemes. So we're going to do a little bit of this today, and we will also, during the class, use some other tools, right? Then lab 4, again, is man in the middle, but for iOS. And in here we look at the application use SSL, does it weaken ATS, is it validating SSL certificates correctly, how to bypass pinning, and all this kind of stuff. Then lab 5, we modify IO files. So now when you decompile an application, you can get you can get like the binary, right? And you can patch the binary and modify it, but sometimes the application is written in JavaScript. So you are going to get the JavaScript back. And in those cases, you would change like, you can change the JavaScript and then install the modified application, and that will also work. So we also have some exercises for kind of more modern iOS applications as well. And then we look at usage of Hydra for making modifications in binaries and stuff like this. Lab 6, this one is quite heavy. I think it's 86 pages. Here we look at a lot of instrumentation stuff for iOS. So we use Secret, we use Flex, we use Passionfruit. And we also use some CDA tricks to bypass rule detection and stuff. So there's a lot of case studies, use real applications, I think Skype, LastPass, some popular applications on Android. I think I mentioned Periscope and Shopify. So quite relevant for, kind of not only using like toy applications to practice, but also using some real ones, right? Then CTF, again, with some IoT applications, because it's interesting that you can find IoT vulnerabilities by looking at the mobile application alone, even if you don't have the device. So in the CTF, you have some stuff like this. And then at the end, this is kind of advanced instrumentation. So we have like an entire day dedicated to FRIDA, objection, Radari tool. There's a lot of tools like this, right? So here on the slides, I'm just summarizing because we have one lab for Android and one lab for iOS, but it's basically the same thing about FRIDA and objection. In one, we will focus on Android, and on the other one, we will look at iOS, but we're going to bypass rule detection, hook crypto functions to leak data using FRIDA, how to get started with FRIDA and objection, how to use FRIDA and objection when you have root and when you don't have root. So there's a lot of stuff like that. And then in labs 3 and 4, we use the runtime mobile security, among other things, but it's really more about custom hooking with FRIDA, right? Like how to find what to hook in the application, how to hook it, what methods are available, what are the parameters, how can you get started to write your own code to do this and all that. And then we cover like FRIDA, objection, and MS. And then we have other labs about FRIDA and Radari 2. So this is kind of heavy on the, to improve like the instrumentation workflow, but again, doing more kind of a little bit heavier on the reversing and stuff. So it's like basically an entire day based on hardcore FRIDA, Radari 2, objection, all this kind of fun. Okay, and then at the end we have a CTF for Android, CTF for iOS. That is the end of what the course is about. So now we start with the actual content. So let me take a look at the chat. Question for the group: does cross-site request forgery exist in mobile apps? What do you say? Anybody? Cross-site request forgery on web applications, yes, but on mobile applications? Possible, not possible? Thoughts? Yes, with a question mark? Yes, correct. So it is possible with deep links, right? Which is the first thing that we're going to look at, right? So with deep links, we can achieve user impersonation. We can achieve attacks to bypass authorization control and make phone calls and all that, right? It depends on what the application does. So deep links are basically URIs that you can use to navigate different parts of an application, and they are available on both Android and iOS. They can have custom schemes, right? So you can have like your own URL handler, like social app, and then homepage, and then somebody clicks on this, and then that app is going to open, right? And this is true for Android and iOS. Both can kind of do this, right? They can register a URL scheme. Another option is that they can register specific URLs so that when a specific URL is opened, they can register that this application is meant to open those URLs as well, right? So it doesn't necessarily have to be like this. So it can also be like HTTPS, whatever. But this will make more sense as I make more progress in the webinar, right? So you can have like social app profile, profile picture, and things like this, right? So you have URLs like this that we can invoke and do stuff with, right? So how to register links in Android? So you look at the Android manifest, and there should be something like this, right? So you have some application, deep link activity, and then browsable is not necessary, but if you see it, you should get excited because if browsable is not available, then the URL scheme is defined, but only malicious applications inside the phone can call it. But if, in addition to that, it is browsable, then you can call it from the browser. So that is pretty cool because then you can have like your own attacker website, and when somebody clicks on something, it goes back to this, right? So in this case, we have scheme host path, right? And then this becomes like some application, get credentials for a user, right? So just a dummy example of what this could look like, but this is the structure. So you have to define a scheme, a host, and a path prefix in the case of custom URL handlers, right? So for this, we're going to use Periscope. Now, at the end, if you send me an email, I can give you access to all this. So all these applications will be available for free for you to play with. But this is the first scenario that we're going to look at. And in here, we're going to look at Periscope, right? So in Periscope, there was a cross-site request forgery vulnerability using a deep link. If you get the one from Google Play, it won't work because then this was patched. So we have like the vulnerable one in the course. And in here, you basically need first to create an account and you just log in, right? And then once you log in, you need to then decompile the APK to figure out in the code what is going on, right? So you can use, for example, APK tool for this, and then look at the Android manifest, right? So if you look at the Android manifest, you see browsable. You can look for browsable directly, and then here you can see that this activity is browsable, and the host is Periscope, and the scheme is HTTPS, right? So as I said before, it does not necessarily have to be a custom URL scheme. It can be like a normal URL, right? In this case, the intent filter is HTTPS and Periscope.tv, right? So you could also call Periscope like this, right? So that's important to know. Then you can also have like host user and then scheme PSCP for Periscope. So it's both ways, right? So Periscope defines both things, but just mention that it can be both ways. It can be a custom scheme or maybe not, right? So it depends. It's going to depend on the application. Just to say that those are the options, right? So one option to test this would be to use Deep Link Tester, right? Or some sort of application where you put in the URL, and then when you click on it, it opens the app, right? So you can have Periscope user and then some username, and then when you click on it, it opens that user, right? So if you have Deep Link Tester, you put the URL, go to this application you can get on the App Store, by the way. So no need for anything there. And then here you just put the URL, go to URI, and this opens the user, right? So what we want to do is the cross-site request forgery to follow any user that we want, right? So this only opens the user, but it doesn't follow it yet, right? We can also use ADB, right? So we can do ADB shell, and then Android intent action view, and then Periscope the user, whatever, right? Or we can use Browser. So in Browser, you can scan the browsable activities of the Periscope application like this, run scanner activity browsable and stuff. And then this will give you some output like this. So it's telling you which are the invocable URIs. Now, I have to tell you that Browser is not perfect and it will miss some of the URIs. but at least it gives you a starting point of some URI. So just don't believe everything that browser tells you, and don't believe that this is the full list of URIs available. You have to look at the Android manifest and think, but this is still a good starting point, and there's going to be some URIs in here. Then another thing that we can do is to invoke the actual URI using browser like this. So we can do run app activity start and then data URI, and we use the user, right? So a malicious website, because the activity is browsable, can also do this. So there's an example here. And if you're lazy, you can use ADB to open this in the browser. And then from the browser, you can click on open user, and it's going to open the user. And then if you click on Periscope cross request forgery demo, it will follow the user, right? Because that link will add this follow at the end. So this is the cross request forgery vulnerability, right? So you can do this with Deep Link tester, you add the follow, go to URI, and then you will be following it. Following the user, you can do it with ADB shell, then the URI, and then at the end follow. And that also works. Or you can do it with browser, same thing, right? You do app activity start, and then data URI, and the same user with follow, right? So either way, you will be following the user. And from a malicious website, it's just going to be a click, right? So open this and click on Periscope cross-request forgery demo, and then you will be following, right? So this is how the links look on that website. So you have an href to just open the user, and then another href to the cross-request forgery demo, and that will simply follow the user, right? So yeah, you can use that URL. And to mitigate this for different purposes, right? In case we have some developers attending, what you need to do is to prompt the user before the action happens, right? And then mitigate tabjacking attacks, which is another matter. But mainly, if you request a confirmation from the user before the follow happens, then that is basically enough to mitigate the problem, right? So with this, I'm going to start a demo for Periscope. So let me see if it works. Yeah, so you can read my screen, right? So I'm going to go here to the Periscope manifest, right? And we can see here that we have this Android scheme and all this, right? So this is the first thing that you would do to look at the manifest and stuff. And then what I'm going to do is I'm going to open the user, right? So, okay, so you click on open user here, and you can see that I am not following the user, right? Because I have the follow button. This would be that I'm following, right? Now I'm not following, okay? Now I'm going to click something here. So this is closed. And now if I open the browser again and I follow the user, I clicked on the wrong link. So I have to click here, right? So this is the follow. Then this would work if this had not been open. So now it would work. So I go here and I click the follow. And now you can see that I'm following, even though I didn't give my consent or anything. So random user clicks a link on the internet and stuff happens in the mobile app, right? So this is the request forgery on mobile apps, an example that happened to Periscope, right? So, so yeah, this is the end of demo. And now we can move on to the next. So now let's take a look at how to use deep links, but make phone calls, right? So we can find and exploit URL handlers, right? So this is kind of the same thing, but instead of for Android, for iOS, right? So the first thing that we need to do is to find and exploit URL handler. So there's many ways that you can go about and do. You can use the phone directly. You can check, for example, go to get the IPA file uncompress it and look at the info plist, right? So this would be one way. So then you look for the bundle URL schemes, and you will see that there's DVI and DVI Swift, right? So those are the two URL handlers. Another way is with Xcode, right? So you open Xcode, then you open the application in Xcode, then you click here on the application, you go to info, and then URI schemes. Here you have the URI schemes for the application. That's another option. Another option as well is using, for example, Filza, and then open the info plist from Filza or any other. There's many ways to do this, right? So in the course, you will see a lot of approaches to the same thing, because sometimes one method works or is more convenient, so it's good to have several options. So this means the application is going to open DVI Swift and DVI like this. So both URIs are going to be open in this application, right? Then what you need to do is to look for the app delegate, right? Because the app delegate is the part of iOS applications that is going to handle how the application is open. So if there's a URL handler, typically is going to be here. So one way to find it is just to find .name app delegate.swift, and then that will show you where the app delegate is, right? So in this case, we have in the app delegate, we can see that there's an application. This is the application. This is the open URL stuff, and then we have the handling of the URL itself, right? So what is the application doing with the URL that we send to it? So it's looking for separated by phone call number, right? So it's looking in particular for this string, and then it's going to split the URL, and then it has this check, right? So since the argument is an if the argument if you can split it, and like the second part of the URL is something, right? So if it's different than nil, then it assumes it's a valid number, so it's good, right? So you need to give it a number after this, and then it will try to call this, right? So this is an example of attacking URL handlers in iOS, right? So how the vulnerability will look like, right? And that's the end of the controller. And then using Xcode, it would look something like this, right? So you have the application, appdelegate.swift. This is the application function. And in here we have the split. And then a little bit further down, we can see that is getting the second part, right? So it's splitting the string into this. So you will have some stuff at the beginning, and then the phone number here. The beginning is 0. What's after this is going to be 1. So it's getting that part 1. So what is after the number? And then it's casting that to an integer. And if it's different than nothing, then it assumes it's valid and it tries to call the number, right? So that is the problem. So with this, we can try to call numbers, right? So we can do, we can use the URL handler, phone call number, which is what the application is expecting. Then we pass here the random number and it's going to call it, right? So you can do this from a jailbroken or not jailbroken phone. It really doesn't matter. In this case, for this particular exercise, you can do both. And you also have this link here to practice. So I'm already hosting that for you so that you can try that. And this is what the HTML looks like, right? So we basically have an href with the URL handler, and then this is the number. And then here we're just displaying it because we're nice and we want to know what we're doing, but otherwise this would in a real attack be hidden, right? So you click on this, this will prompt the user open in that vulnerable insecure app, and then you click on open, and then it will try to make the call, right? So this is the issue, right? So it's the same thing as we saw in Android, but for iOS, right? So yeah, the ability to call phone numbers in mobile devices is interesting, right? Because in mobile devices, if you can do this, you could be calling a premium number and make money from people keep clicking on your link. So it's still, not just for pranking purposes, but also it can be a serious issue, right? So let's take a quick look at this. So we have, let me check here. I think the manifest. So this is the info plist of the vulnerable your app version 2 for iOS. So in here, you can see that this is the bundle URL name, and I'm not sure if this is too small. Okay, sorry. So basically, there's bundle URL types, and then here you have the bundle URL name, and then bundle URL schemes, and inside of that we have the URL handlers. So we can go ahead and try to exploit it, right? So this is an iOS device, and here we have two URL handlers, right? So if I click on the first, I have to tap on the phone, of course. So I get a prompt for opening it on the application, and then I open, and it says success, calling this number, right? So it worked. This web views is for later. And then if I go back to the website, and instead of using the first link, if I use the second, right? Now I'm tapping on the second one here. I also get the same prompt, and it also works, right? So sometimes applications can register multiple URLs, right? So this would be an example of attacking deep links in iOS. Now, like in Android, it could be the case that the URL is not a custom URL scheme, it's HTTPS something, but the concept is the same for attacking, right? So with this, let's move on. So now let's take a look at XSS attacks and data exfiltration on Android and iOS. Okay, so with web views and data exfiltration on Android first. So a web view in Android is a native Android object that acts like a miniature web browser, right? So this can load web content like HTML and JavaScript in the context of an Android activity. Web views are useful when you need to have extensive control over the web content being loaded, and we have interesting properties, right? So web views can have as many permissions as the app that includes it, right? They can explicitly enable execution of JavaScript. They can load local as well as remote web content. And native Android functions can sometimes be accessed from web views with the help of JavaScript with JavaScript interfaces, right? All potentially interesting attack vectors. Now, in more modern versions of Android, these have been many of these functionality has been turned off by default, but there's still developers that, for whatever reason, enable them. So, still a relevant attack. So, how to attack web views? First, we need to try if there's HTML injection, right? So even if you only get HTML injection, this can still be useful for phishing. Like, for example, you could have a fake login page, and then, if some user sees that, because on the device, typically, the URL is not going to be displayed, then what is going to happen is that they will have no way to know if it is the real page or not, right? Then we can also do XSS, right? So with XSS, we can change the page, we can invoke functionality from JavaScript, and sometimes, depending on how the web view is configured, we can also exfiltrate local files, right? So we're going to look at some examples of how to do this on Android and iOS today. And another thing is that we can also have like user impersonation using cross-site request forgery with XSS, depending on the application. So for example, the application has XSS, and then this XSS happens in a page on a website, then maybe we can also cross-site request forgery that website through the mobile app, through an XSS in the mobile app, right? So sometimes this can happen. So these are all valid scenarios for attack. Now for this part of the webinar, we're going to use a modified version of Android, right? So if you try to use the normal Android, this is not going to work, but we modified it to re-implement a vulnerability that we have seen in a number of tests that we found it was really interesting, which is not just XSS, but XSS with data exfiltration in Android. Another cool thing about this exercise is that this application is written in Kotlin, but if you decompile it, you will notice that you get the Java back, right? Because Kotlin is kind of this language that is on top of Java. So just to show you that we don't do just Java applications, so there's like some Cordova, Apache Cordova exercises. And this one is, for example, using Kotlin. So there's some variety in the course, I mean. And yeah, so for this, this one is not going to work. You need to get the one from the training portal for this to work, because we changed it. And first we need to create some files, right? So because we want to do the data exfiltration, first we need to make the application save some data so that we can steal it, because if we don't save data, there's nothing to steal, right? So for this, in Android, there's an option for insecure data storage, and we're going to add shared preferences. So you can add, for example, shared preferences, my secret user, my password, and then you click on save, right? So you go to shared preferences part 1, enter your some credentials there and save, and then you do the same to create a SQLite database file. You can enter the same credentials if you want, and that is more or less how that looks, right? So, and after all that, you can navigate to the input validation exercise, which will look like this, right? So you click on input validation exercise, and then we can start inserting payloads and see what happens, right? So you can insert like hello with H1 and see if it shows bigger, right? So you enter this, hit display and hello. So you will know this is the modified version. In the real version, there's only one field, right? So because we want to test this from internal storage and external storage to show other attack vectors. So this way you have like more possible scenarios to play with. So then you can try if JavaScript executes, right? So you can do image source X on alert 1 or script alert 1 or all these kind of payloads. And then we'll see that this also works. So then the next thing is, okay, so I have XSS, but what is the security context in which this XSS is running, right? Because if it is from file, then that means higher privileges and higher likelihood that we can steal local files from the phone, from the application, and send it to an attacker, right? So if you click on display, you can see it's loading stuff from file, and this means that like the planets, let's say, have aligned for us to be able to use this XSS, not just to alert them stuff, but also like to steal files from the application and send them to an attacker, right? So it's two files, one on data and one on the SD card, and this is also for you to play with, because when there's like HTML on the SD card, then a malicious application could change this HTML and get XSS that way, right? So because a lot of applications can write to the SD card, not just this application, but any application on the phone, it could insert something here, and then you would have XSS, or you could extract the SD card, right? An attacker with physical access could extract the SD card without even knowing the unlock pattern of the phone, plug it to a computer, put some XSS in here, and then when the user opens it, they get XSS, right? So that's another thing, right? Now, for data exfiltration, we need to know the paths of what we want to steal, right? So if you have root, you can like navigate to data directory, and you can see what the files are. And in this case, we want to steal shared preferences, users XML, and databases Xcode, right? So those are the two files. This is a SQLite database. This is an XML file, and we will showcase both. This is what the payload look like, right? So we basically create a new XML HTTP request, get the user's XML, and then you send and you alert that, and that is pretty much it. So if the alert shows you the file, this means JavaScript can read it, so JavaScript can forward it to an attacker. So this allows data exfiltration. This is how it looked like, right? So you do display, and then in the case of the XML, we get this, and in the case of the SQLite, database, we get this, right? So the SD card I have already explained. Then if you have the browser installed, you can, for example, get other files like from the system or from the browser. It's going to depend, right? So there can be files on the phone that the application can also read. And in that case, you can also read those and send to all the attackers. Have more information about the phone or something. Some examples about this during the course. So this is how that looks like. These screenshots in particular are from a real phone running Android 9, Xiaomi, if you're interested. That is how it looks like, right? So you can read system files and SQLite database files and stuff. So in summary, we can exfiltrate application data files, system files, files from other apps, so anything that the app can read, right? So if there's permissions for the app to read it, and the app is vulnerable to this, then you can steal all that, right? And you can also read any SD card file on the phone. You just need to know the location, right? So yeah, so this is kind of the methodology. Can we also run JavaScript? Yes. What is the privilege? What is the security context in which it is loaded? So it is file, privilege context, not protected by the same origin policy. We can read local files, right? And then how to filter files and all this. Yeah, so that is pretty much it, right? Well, another thing is if you do ADB shell, you can also like go to the SD card and you can see the HTML here. So you can do ADB pull of this file, modify it, ADB push, and all that. So there will be a way to access the application, right? So we can modify this and we can inject like any script that we want inside of the HTML. And this will result in a persistent XSS vulnerability in the application, right? So you can have the two scenarios that I mentioned, attacker with physical access to the device or malicious application on the phone that can also write the SD card, right? And then when you click on input validation XSS, you will get immediately this prompt instead of having to type here anything, because it is a persistent XSS. So anytime you click this, the XSS is going to work, right? So in the root cause analysis, if, for example, you decompile using mobsf to just check on root, you can do ls-l with the t for the, so that is sort by time, and the most recent time is at the top on the uploads directory, and then you can get the decompiled files from there, and then you can grep for external storage and see the file in there. Okay, so yeah, I think I'm going to skip this over a little bit because we're a little bit done on time and I still have demos to go. But yeah, this is okay, sorry. This is the actual vulnerability. You can see that the vulnerability is that it reads the file, the name input from the user, and then it does document.write. So it's really a DOM XSS on a web view, right? So it's a little bit weird. It's not a normal kind of on Java's the application is rendering, but the actual XSS is DOM XSS. But still, all the other things that I mentioned are relevant. So let me just go straight to the root cause. So if we look for this file, then this points us to the culprit files where this file is being referenced, which is the XSS activity. So we can look at the affected file and we can see why this works, right? So JavaScript is enabled, allow universal access from file URLs is enabled, allow file access from file URLs is enabled, and allow file access is enabled, right? So all the insecure settings are enabled. This is why this works. In general, in modern Android versions, most of these features are disabled by default, so a developer will need to enable them for this to happen. But it still can happen, right? Yeah, and then in the end, you can see the file URL here, right? So that it's being loaded from file. So that is more dangerous because there's no same origin policy. So how to fix this? Use text views instead of web views. If you have to use web views, disable as many settings as possible. So for example, try to disable JavaScript, disable file access, all that stuff. So you want the minimum possible settings for the application to work. Output encode user input prior to rendering it on any web view. And avoid DOM XSS things as much as possible. So try not to assign user input to inner HTML, document.write, location, href, and things like this. And the overall XSS prevention has a lot of material on this. So I'm just going to do a quick demo about this. So where is this? Here. So I'm going to go now for the XSS demo, right? So I already used in Android, I already entered some credentials, so I won't have to do those steps that I mentioned on the slides. So I go to input validations, XSS, and we can see here that we have internal storage, right, and external storage. So I can paste this in here, and if I hit display, you can see that we got an XSS, right? Now, if instead of this, I try some of the data stealing stuff. So I'm going to copy this. Oops. Okay, like that. Go here. Work. Okay, so I click this and I paste this. So if I hit display, you can see that I can read the XML file where the credentials were being saved, as well from the SD card, right? So that is the external storage one. And now, let me see what else can we run. Let's try one of these. I'm going to paste this, and I'm going to I'm not sure if I'm copying the whole thing, but anyway, let's try. Yeah, I think it's missing the chunk. So yeah, in this case, we couldn't read the file, but you can see it's still reading the file. So it's going to depend. This is what you will get if the file doesn't exist. And in this case, the payload was not complete. But I mean, I think you saw enough to see how this works. I think this one is probably the SQLite database. That. I go here, paste it. You can see that we can also read the SQLite database, and we can see the credentials here. You can see my secret user, my secret password. This is all being displayed in there, okay? So with this, that's the end of the demo. So let's move on. So we can do the same thing with web views and data exfiltration on iOS, of course. In this case, we're going to use some going secure app, but we're going to use a scenario that is actually relatively common. I mean, a little bit less common now, but still happens. So you basically have to go to the web view issues and start challenge. And then in here, you just type some stuff. So you can try, for example, h1 hello, and you will see that the hello is bigger. So we can also try to retrieve files from the phone, right? So we can try to retrieve data usage or other stuff like this. We can try alert one, alert location. So again, we can try all these things. So if we try alert one, it will look like this. We try alert location. It shows us. Now, very interesting here is that we have about null. So this means This is kind of the same equivalent of what we saw before with Android loading the web view from a file URL. So in this case, we are using an about null URL. So basically, there's no URL. So this is the same thing. So this means that the application does not have the same origin policy. So we can read local files and forward them to an attacker. So you can see alert one gives us one. If we do alert location, you can see we are on Apple web data. We can read SQLite databases and stuff from the phone, right? And we can like steal, for example, the cellular usage and send it to an attacker, for example, right? So these are some of the things. So methodology-wise, this is kind of the process you would follow, right? Alert one, alert location, and then try to read some files from the phone, right? So to find the culprit for this, one way would be to grep for WK web views and UI web views. So this is the new kind of web view, and this is the old one. This is kind of weaker and more prone to XSS. And this is how this would look like, right? So the output can look like vulnerabilities, can say injection, controller, and this shows you like the vulnerable file. And then inside of this, you can see why this happens. So this is how a string concatenation looks like in Swift. So you have load HTML string, which is kind of our red flag. So you should always try to look for load HTML string and try to see if there's user input finishing here. So in this case, we have a name variable that is being concatenated like this using Swift. And the problem also is that the URL is nil. So this means because of the higher privileges of the application, we can also exfiltrate files in iOS. This is how it looks on Xcode. To summarize, our UI web view is weaker by default. It enables JavaScript, has file access enabled, so all the kind of insecure features are enabled by default. And the WK web view is kind of the newer type of web view in iOS, and this has all the security features enabled by default. It's faster and is what developers should use, right? So this is like the way to fix it. So with this, let me do a quick demo about this. So we go to web view, start challenge, and I go here. For example, let me go straight to getting the files, right? So I'm going to copy this one, and I'm going to paste this here. Yeah, and you can see that it takes a little bit of time because it's reading like a big file from the system, but we have access to this SQL file, right? So as long as you know the location of the phone, on the phone, you will be able to see this. Okay, so a little bit short on time, so I think that is the end of the webinar pretty much. So this was all to promote the session in October. So it's going to be 3 days, October 26th to 28th for CIFCon. It's going to be online. So no matter where you are, this is the URL. And if for any reason you cannot make it, you can get in touch and maybe we can give like some kind of self-paced access, right? But that is it. If you have any questions, now would be the time to ask. Again, the session is in October. And if you want the slides, the vulnerable applications to practice with, and we will also have the recording, just send me an email and I'll give you access. That's also no problem. So with this, you can start asking your questions, but that's the end of the presentation. Any questions? No questions? Everything clear?
Question you may ask, typing on the chat or put your hand up. The hand is in the right bottom corner.
Thank you for the nice feedback. And yeah, and all this, like when I said send me an email, this is all for free, right? So I'll give you access to everything, all the webinar material for free if you are interested. Any resources for further testing and learning? If you are asking about free resources, the OWASP has a very good project, which is the Mobile Security Testing Guide. They are pretty good, and they have some nice content. Our course is more based on real tests and what we have seen in practice. So the Mobile Security Testing Guide has a lot of good material, but in many cases they use like crackneys and applications like this. And in our case, we have like this is an application that was mandated in South Korea. Okay, this is an application that Chinese police use to spy on Muslim minorities. So we have applications like this in the course, right? And you get access to all those and stuff like this. We also have some toy apps like Dumb Vulnerable Insecure app that I showed. But still, the attack is relevant because we have seen this in real applications having this kind of URL. But yeah, that would be a good place. The Mobile Security Testing Guide has a lot of material. Well, thank you for the nice feedback. Yeah, I'm still around if somebody has questions, or if you have questions later, you can shoot me an email. Hopefully see you in October.
Someone is typing.
Yeah, somebody's typing, so I'm just keeping an eye on the chat.
The last question. Oh, thank you.
Awesome. Well, thank you. Thank you very much for coming.
Abraham, thank you very much for a very nice lecture, presentation. Attendees, thank you very much for joining our short webinar. Remember about the ZIFCON conference and about our trainings in the end of the year.